So we talk about network management, and this picture actually is a good idea, gives you a good idea of what the network management is like. If you go to any of these big companies such as AT&T or Verizon, they have many halls like this, where the whole hall is filled with screens and people are watching the screens, all right, managing the network. They are seeing everything that is going on the network. Yeah, we will do that later on. So what is the network management and how and all that? So we will do some part of it as much as we can do, up to 350, 345. So traffic on the network. Basically, so what is network management? We may have talked about this before, but I will just talk about it here again one more time. Is that the traffic on the network has three parts: data, control, and management. Data is what the user sends. Control is what is required, which is absolutely essential to send that user data. And management is what is optional. So management is like in a company, managers are not really required. If every employee did the job they are supposed to do, then the managers are not required. The reason we need managers is because the employees get sick, then we have to find a replacement. And if somebody doesn't do the job right, then you have to correct the errors. So all that is management, right? Management is the optional part, and so that is what we are going to talk about today. So routing messages are control, because if without the routing messages, you will not know how to get from here to there. But to find out how many packets were sent is management, because nobody cares how many packets were sent. We just need to know so that we can pay the bill, right? So that is management. So all components function properly. Control is to management is optional. Examples are detecting the failures of an interface card is management. Monitoring traffic to add in the resource deployment to find out that the link is overloaded is management. Intrusion detection is management. All right. So ISO, which is the International Standards Organization, classifies 5 types of management: performance management, fault management, configuration management, accounting management, and security management. Performance is just measuring the load and finding out how much is being wasted and used. Fault, trying to find out who is working, who is sick. Configuration is basically deploying new devices, setting off some devices, and so on and so forth, hiring and firing. Accounting management is paying, making sure that everybody is paid their dues, their hours. And security management is making sure that nobody is doing anything that they are not authorized to do. Right? Clear? 5 things you have to manage. And the same thing applies to networks, by the way. So how is the network managed? Basically, the way it is managed is that every device on the world, every device on the network has a piece of software called an agent. So your laptop has an agent, and everything has an agent. For example, this camera has an agent inside it, a piece of software. That agent has a database, basically, and for each agent there is a management information base, a database is defined that the agent keeps. All right, and anybody, actually not anybody, whoever is authorized to ask can ask, okay, tell me this piece of the database. So this is the manager, network management station. It can ask this agent, tell me how many packets were sent, and it will respond that. Then it will ask how many packets were sent, and this will respond that, and this will respond that. So the key word that you understand here, 2 new words: NMS. NMS is Network Management System, and MIB, MIB, is the Management Information Base. And we networking guys use those words left and right, NMS and MIB.
Is it server or station?
Network Management Station, and you can call it server, that basically doesn't matter. NMS. Actually, it is a station right now. It's not, it could be called a server if it starts serving something, but right now it is just collecting. And so here is another view of the same thing. So these are all the LANs, these are all the networks here and there, these are all the computers. Every computer has an agent. Every computer. If you make any device, you have to put an agent in it. So for example, when we had a company and we were making what? We were making a home fiber box, okay? Just like your DSL box, let's say. That DSL box has an agent which the telephone company can query and find out how much traffic was sent. Obviously, they can also find out from the other end. But they can also find out how much was received here for some reason as to how much was dropped, for example, that is not available at the other end. So every box that is made ever in the world has a agent in it and has a MIB in it. MIB defined for it. So MIB is a defined database structure for each device, and then the other people can just query that device. Yeah.
Every device that can that gets network traffic through it, right? So
Any device that is, so nowadays everything is networked. Even your fridge is networked, right? Because somebody wants to know how often the fridge was, what temperature it was, and so on and so forth. So that's the MIB. Is that?
the unique identifier?
Yeah, right. The question is, that's a good question. Is that, so every device has a unique identifier? The answer is yes. Each device and each data point has a unique identifier, which is coming up.
So MAC address. Similar.
Well, we'll come to that. All right. So you can see this picture, right? This picture is just a bigger view of the previous picture. Is that here is a, now it is called management server. So there is a NMS, and then there is, router has an agent also. You see, routers have an agent, and these boxes have an agent, and these boxes have an agent, and so on and so forth. Every box is an agent. So Internet Management Framework. So basically, we need three things. We need a structure of management information. So we need first to define a language. We need to define a language in which we can explain all this, right? And that language is called ASN1. ASN1 is the language which is defined by ISO and is also used in SNMP. What is SNMP? SNMP is Simple Network Management Protocol. So before ISO was ready, IETF guys figured out that we can do simple things, just getting the data, and so they produced the protocol called SNMP. And then ISO took so long to develop everything that ISO died even before it was born, and SNMP is what we use today. Okay, 30 years later. So SNMP is pretty old but alive and well. SNMP is Simple Network Management Protocol, and that uses ASN1, which was defined by ISO. So that is basically, SMI means the definition language. How do you define it? And we'll give you an example in a minute. Then MIB. Once we have that language, let's say we selected English. Then with using English, we can say, well, for this object, we need to know the number of packets received, and we need to know the time PowerPoint was on, and what application was on for how long. So we can just define those. That is called MIB. MIB is particular to a device, and what kind of question can we ask that device, that is defined in the MIB. And then SNMP protocol. Then we need a protocol which is so that somebody can ask me remotely, right? So SNMP is a protocol that is spoken between the manager and the managed. And right now we are at SNMP version 3. Because version 1 and 2 were not secure, so 3 is the one that we use. So what is ASN1? ASN1 is Abstract Syntax Notation 1. It was developed in 1984 by ISO and ITU. ISO is the International Standard Organization, ITU is the International Telecommunication Union. This is the telephone organization, and this is the just general organization. And so the latest ASN1 is 2002, and so this is used to specify the protocol data structures, and everything uses ASN1. For example, email, directories, H.323 VoIP, SNMP, everybody uses ASN1. So this is very commonly used. And so what ASN1 is basically a language for defining data structures. And in this language, first thing is that we define certain things. If we said this is an object type 1, that means it is a Boolean. Object type 2 is an integer. 3 is a bit string. 4 is an octet string. 5 is a null. 6 is an object identifier. 9 is a real number. And so on, the list goes on. Alright. So anytime anybody says object type 1, they know that it is a Boolean, 0 or 1. Right. So that is ASN1. Now using these, you can make more complex things. For example, you can make sequence or sequence of or choice. So let's show the example. Well, before we go to the sequence and sequence of, these are some of the data types. Integer could be 32-bit integer, but mean minus with signed integer, right? Or it could be integer 32. Okay, there is an unsigned 32 and there is a signed 32. Then there is an octet string, which could be any text up to 65, which is 2 raised to whatever, 16 is it? Bytes long. And then object identifier could be any ID. Address is 32-bit internet address. Counter 32 is a 32-bit counter that goes from 0 to that one and then that's back to 0. 64 is just 64-bit. Gaze is something that goes and gets stuck at the highest possible value. Time ticks. So these are some of the things people have defined different things using ASN1. So here's an example. So suppose your home address. Your home address is of the type address type. So that is the type of the address. And this type has a sequence of. Sequence of means it is a vector of name, which is an octet string, a number, which is an integer, a street, which is an octet string, a city, which is an octet string, a state, which is an octet string, and zip code, which is an integer. Alright. So using integer and octet strings, we are able to make a new type called address type. So now we can say, what is your address? And I will know how to read that address. Right. So now you need how to put this together. So how to say this thing, and so for that you need encoding rules. ASN1 only specifies the structure, but then you need how to encode this structure to the bits on the wire, and there are many encoding rules: basic encoding rules, tagged encoding rules, XML encoding rules, distinguished external rule, and BER is what we will talk about, but I think two most common are BER and XML. BER is basic encoding rule, and everything is encoded as a tag, length, and value, TLV. So let's see an example. I want to put this thing: John Miller, 126 Main Street, Big City, Missouri 63130. So I write it down as first field is a sequence of 80 characters. No, sorry, is a sequence, not 80 characters, is a 80 of 2f characters. Length is 2f. So 2f, you can calculate how much it is. 16 times 32 plus 15 is 32 plus 15 is 47. 47 characters. The first thing there is 04, which is octet string. Its length is 12, 0b, and that string is 4a, 6f, this, and it will go up to here. So you can see this is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
P is 11.
I'm sorry, what is it?
A is 10, B is 11. So
So this 0b, b is
11.
11, right? Yeah, 11. Okay, b is 11. All right. Then the next thing is 126, and that be encoded as an integer type, which is 02, and length is just 1 byte, and that byte is 7E. Then we took the main street, which is an octet string, and then we took city, which is an octet string, and then we took the state, which is an octet string, and then we took the zip code, which is an integer of length 2, it requires 2 bytes. Okay, so this is called basic encoding. Yeah.
How do you know what are the codes for sequence and integer?
Okay, so this is all defined before. This is defined here. So this one defines at any time, and now I would have, that the address type is first thing is a sequence of, so sequence has a number 80, that was already defined, right? An octet string is 04, integer is 02 or something, right? So those are all defined before, and this thing is what goes in the MIB. In the management information base, this is defined, that anytime you ask the address, it will be like this.
Somewhere there is a list of all of those types.
Oh, that list, okay, so there are 2 lists. First of all, this is the basic predefined list. This one is already in the standard, right? But when you make a new device, every time you make a new device, you make up something like this, right? And this is just an example of that encoded on the wire. When it goes, that address goes on the wire, you have to put it like this. All right. So MIB, Management Information Base. So for every device that is designed or sold in the market, there is a MIB. Your television has a MIB, your computer, your network server, your router, your wireless thing, your phone, everything has a MIB defined for that device. That MIB is published either by the vendor organization, such as for all the telephones, they might have one MIB, and that is published by all the phone vendors. And so then any company which is using all these phones can query the phone and say, tell me how many SMS messages were sent by this phone today. Right? So that is called MIB. So MIB is, and every device type has, everything has a name, and every name has a unique number, and the number is the whole tree. So suppose I want to get a number, I will have a number which is relates to my father's number, and my father's number relates to his father's number, and so on and so forth. So the whole tree number, starting from the ISO, for example, if you want to find out how many IP packets were received by a router, that number is 136124141. Where 1 is for ISO, whose son or child is ARG, whose child is DOD, and the DOD started the internet, and they started the management, MIB, and then they put the IP, and IP receives. So there's a whole tree which is globally unique now. So when you want to find out from a router how many packets they receive, you send them this number, and they know what number you're asking. So this is not your MAC address. Right? Every device, every number that you want to ask has a big string like this, and then you ask for that. Here is the tree. ISO is one of the 3 organizations of the root, and standards and non-standards. By the way, the whole internet is non-standard. Why? Because standards were being developed which never got developed, and TCP/IP took over. So this was a private thing which became really the world standard. So internet comes from the DoD, Department of Defense, and under DoD we have all of these things. For example, if you want to know UDP datagrams, how many datagrams were received, you would say from here, you would say 1.3.6.1.2.1.7.1. Yeah.
Does this correspond to in the labs when we were doing read register?
You were doing what?
The read register things?
Read register. I don't know whether they had SNMP there. If they had SNMP, then you would do that, but no, I don't remember now. Sorry. All right. So, for example, if you want to know how many in datagram, this is the number. If you want to know how many ports, this is the number. How many errors, this is the number. Datagrams, this is the number, and so on and so forth. And this is the type. So this is all defined in some document. Some document you can find out. Actually, it is nothing but the UDP MIB. So if you go to IETF and look for the word UDP MIB document, that document will define that these are the variables you can ask for, and if you want this, you put this number, and will give you the answer a counter 32. All right. So I just took it from a standard, this MIB, and so this is saying IP address table is a sequence of IP address entries. Each entry is a sequence of address blah 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 and so on and so forth. This is what the MIB document looks like, and there are people who just expertise is to design MIBs, and they are management experts. Okay. So the protocol SNMP, and the name actually came from SGMP, which was before this, but SNMP was invented by this guy Marcel Rose, and he jokes about it that SNMP stands for simply not my problem. Actually, the real acronym is for Simple Network Management Protocol, and this is defined in 1988 in RFC 1058. And it is simple because it has only 5 commands. First command is get request, and then the get response, set request, and get next request, and trap. So he just designed a protocol with 5 commands, and with this he said you can do everything that you need for management. So let's see how you can do that. So if you are a manager, you send a request. You can say please set that interface to off. So that's the request. Get request is please read me the number of packets sent, and the response would be number of packets sent is so much. So you need a request and a response. And then you need a trap. Trap which is alert, which goes unasked for. So basically the trap is given whenever something happens. For example, we could say that the counter overflowed or the device went down, something which is unexpected happens, then we basically send an alert to the manager saying that look, take care of it now. So most of the things are request response, but there are some traps. But there are 2 kinds of request. One is simple get request and one is get request next. Why get request next? Is that often you have whole table to be read. So you read the first interface, the whole row came back, then you want to request the second interface, you say get next one, next one, next one, next one, next one. So it is helpful to read the whole table by just doing get next rather than repeating the previous request. SNMP version 2 changed the number 5 to larger number, so now they have more messages: get request, get next request, get bulk request, inform request, set request, response. So it basically made it more general. In particular, it allowed more than one manager. So you could have 2 people managing something, and somehow they will be coordinated, and that is what is done by SNMP version 2. And they had bulk request. That was another one, is bulk request. So you could go the whole table rather than going row by row as you had do in the previous one. So there were some extension in SNMP basically which were more related to getting the data faster. And then SNMP version 3 actually, which is coming last, actually did the security part. But anyway, here is the SNMP message. You have a PDU type, basically which is the version 0 through 3, version 1 to 3 maybe. Request ID, let's see, request ID, this is sequence number, and then error status, error index, name, value. So these are the variables that you want to get or set. Or it could be trap, in which case you will have PDU type, and then what is the trap type, and then the timestamp, and then whatever the names and values are, the trap information. So it's very simple protocol with basically name and values of the objects to be sent. The SNMP always uses for 161 and 162. So the manager's request sent to 161 and the agent sends the traps to 162. And basically it uses UDP. Now let us see. Where does it say UDP? SNMP runs on UDP, SNMP runs on UDP, SNMP runs on UDP. Okay? SNMP runs on UDP. So basically it is a request response, no connection is required. You send a request. If the request is lost, you send another request and you might get the response. Alright, SNMP version 2 already said that there are two key things, get bulk and then an inform request with multiple manager coordination. Alright, so those are the two things which were in SNMP version 2 which came out in 1993. SNMP version, okay, well version 3 we didn't say, but version 3 is basically security update and that's what we are using. So that brings us to the end of the management protocol, and management is used for initialization, monitoring and control. So let's see. Initialization is when you want to bring up a device, you might send a command saying that bring up, or set the status to on. Monitoring is when you want to get the information that, okay, read me this counter, and control is again same thing like initialization, you can set something off. And SNMP has only 5 to 7 commands, and the standard MIBs are defined for each object. Every new object, every new protocol, every new thing that is done in the networking has a MIB associated with it, and these MIBs are specified using ASN1 encoding. And then SNMP version 2 increase the number of commands so that you can get bulk and some simple security. Now let's see. So what we have done is pages 771 to 800, and you should be able to do problem P1 through P8 and the question R1 through R12. And here's the homework. Now obviously the homework is not due, but it will be in your favor to do this. So you want to get the BER encoding of add, and his date is 259. That's all. So this is and so the octet string type is 4 and integer type is 2. So this is an integer, this is an octet string. How do you encode this? Yeah.
Is SNMP just one of many protocols to access the MIB? Because it seems like MIB predates UDP by a while.
Yeah, right. MIB predates everything else, because I mean you couldn't design a protocol without the MIB. And so the question is whether SNMP is one of the many protocols that uses the MIB. The answer is yes, but those many are basically not used anymore. So there was something called CMIP, which was the ISO protocol, which was supposed to take over the world when really the management is required, but SNMP had already taken over the world. So SNMP right now is the major or the most frequently used protocol. Everywhere they were using CMIP, they are replacing it with SNMP. All right. Now I want to show you, I mean, basically a simple MIB